So we have this equation right over here. 12 to the negative 2 power times 1 over 72 to the 5th power is equal to 2 to the a power times 3 to the b power. And what I want you to do now is pause this video and find values of a and b that satisfy this equation, where a and b are two integers. And I encourage you to use all of the exponent properties that we have now learned in order to tackle this. So I'm assuming you've given a go at it, so now we can work through this together. So what I'm going to try to do is get these numbers like 12 and these numbers like 72. I want to express them as products of powers of 2 and powers of 3. So 12, for example, is equivalent to 3 times 4. So I could write this as 3 times 4, and all of that is going to be raised to the negative 2 power. Now, why am I interested in 3 times 4? Well, 3 is clearly a power of 3, and 4 is clearly a power of 2. This is 2 squared, and we're actually going to write it as 2 squared in a second. So this is 3 times 4 to the negative 2 power. And then 1 over 72 could be rewritten as, so this is going to be times 1 over 8 times 9. 72 is 8 times 9. 8 is a power of 2. 9 is a power of 3. And of course, we're going to raise that to the 5th power. And that's going to be equal to 2 to the a times 3 to the b. And I'm just going to keep trying to simplify the left hand. And then we'll, in terms of powers of 2 and 3, and then see if we can match what a and b need to actually be equal to. So let's look at this right over here. So this, if we have the product of two numbers raised to an exponent, we know from our exponent properties that this is going to be each of those numbers raised to the exponent, the product of that, or the product of each of those numbers raised to that exponent. So it's going to be 3 to the negative 2 times 4 to the negative 2 power, times 4 to the negative 2 power. And now this right over here, let me just rewrite it like this. This is going to be the same thing times 1 over, let me write it this way, times 1 over 8 times 1 over 9. And we're going to raise that to the 5th power. Now, 3 to the negative 2, we could just keep as 3 to the negative 2. That seems like a nice form to leave it in. So let me write that as 3 to the negative 2 power. Now, what is 4 to the negative 2 power? Well, 4, let me introduce a new color here. 4 is the same thing as 2 squared. So it's going to be times 2 squared to the negative 2 power. 2 squared to the negative 2 power. Now, what is 1 over 8? What is 1/8? 1/8, you could view this as 8 to the negative 1 power. Or you could view this as 1 over 2 to the 3rd power, which is the same thing as 2 to the negative 3 power. And these are consistent because remember, 8 is the same thing as 2 to the 3rd. So this is 2 to the 3rd to the negative 1 power, which is 2 to the 3 times negative 1, which is 2 to the negative 3 power. So 1/8 is 2 to the negative 3rd power. And by that same logic, 1/9 is equal to 9 to the negative 1 power. Or you could view it as 1 over 3 squared, which is equal to 3 to the negative 2. And these, once again, are consistent because 9 is 3 squared, and you're raising it to the negative 1 power. So once again, that's 3 to the 2 times negative 1, 3 to the negative 2 power. So this is going to be equal to, when we're raising everything to the 5th power, so 1/8, we just established, is the same thing. 1/8, I'm having trouble changing colors. 1/8, we just established, is 2 to the negative 3 power. And 1/9, I'm running out of colors. 1/9 is 3 to the negative 2 power. So let's keep simplifying this. We have our 3 to the negative 2, 3 to the, I'm feeling I'm going to need some space. So 3 to the negative 2 power. Now this part right over here, I can introduce purple again. That part, that's 2 to the 2nd power, and then that raised to the negative 2 power. Well, we've already seen that's the same thing as taking 2 to the product of these two exponents. 2 times negative 2 is negative 4 power. And then we're going to take each of these. We've already seen taking the product of two numbers and raising it to an exponent. That's the same thing as taking each of those, raising it to the exponent, or taking the product of each of those raised to that exponent. So it's going to be times 2 to the negative 3 raised to the 5th power times, we're in the home stretch, times 3 to the negative 2 raised to the 5th power. So once again, this is going to be 3 to the negative 2 times 2 to the negative 4. I think you see the end now. And now what is this? 2 to the negative 3 to the 5th, and then that raised to the 5th. Well, we multiply these two exponents. That's going to be 2 to the negative 15 times 2 to the negative 15th power. And then what is this going to be? Negative 2 times 5 is negative 10. So this is going to be 3 to the negative 10th, 3 to the negative 10th power. And so what's this going to be equal to? Well, if we multiply this one, let me do this in a new color. If we multiply 3 to the negative 2 times 3 to the negative 10, we have the same base. We would add the exponents. So that's going to be 3 to the negative 2 plus negative 10, which is the negative 12th power. And then we have a 2 to the negative 4 times 2 to the negative 15. That's going to be 2 to the negative 19th power. 2 to the negative 19th power. And we want that to be equal to 2 to the a. Now we go to the beginning, going back to our equation. We want that to be equal to, whoops. We want that to be equal to 2 to the a times 3 to the b. Well, we have 2 to the negative 19 power, so let's let a equal to negative 19. A equals negative 19. And we have 3 to the negative 12, so let's set b is equal to negative 12. And we are done. So all we did, this was just an aggressive application of pretty much all of the exponent properties that we actually know. And it's actually kind of a satisfying problem.